Welcome to a transformative journey into the heart of modern software development. Today, we're unraveling a game changer, how generative AI is revolutionizing CI/CD for Java applications. Get ready to explore a future where your pipelines build themselves. Have you ever felt the grind of setting up a robust CI/CD pipeline for your Java projects? The endless YAML files, the intricate Jenkins files, the daunting task of integrating various tools from Maven to Docker to Kubernetes? It's a complex puzzle, often demanding specialized expertise and countless hours, time that developers would much rather spend writing amazing code. In the dynamic world of software, continuous integration and continuous delivery, CI/CD, are the bedrock of agile and efficient development. At its core, C is about developers integrating their code changes into a central repository frequently, often multiple times a day. Each integration is then verified by an automated build and test process. CD picks up where CI stops, focusing on automating the entire release process, ensuring that validated code is always ready for deployment, or even automatically deployed to production environments. This continuous loop of development, testing, and deployment is crucial for delivering high-quality software rapidly and reliably. It's what separates the fast movers from the slow ones in the digital race, ensuring consistency and reducing manual errors across the board. But let's be honest, the path to a fully automated CI/CD pipeline is often fraught with challenges. Think about the manual effort involved. Painstakingly writing and maintaining configuration files for different environments, debugging syntax errors in complex YAML or Groovy scripts, and constantly keeping up with the latest versions of build tools, testing frameworks, and deployment targets. This isn't just about time, it's about the steep learning curve required to master a diverse set of technologies, leading to inconsistencies across teams and projects, and ultimately, slowing down innovation. The maintenance overhead alone can be a nightmare, as pipelines become brittle with every new dependency or infrastructure change. These pain points are universally felt, holding back even the most agile teams. Now, imagine a world where these pain points simply melt away. This is where generative AI steps in, a true game changer. Generative AI is not just about automating repetitive tasks, it's about intelligent creation. Unlike traditional automation, which executes predefined rules, GenAI understands context, learns from vast datasets of existing, successful configurations, and can then generate entirely new, optimized code and infrastructure configurations from scratch. It's a paradigm shift, moving us from manual configuration and brittle scripts to dynamic, context-aware pipeline generation. Picture an intelligent assistant that knows the intricacies of Java builds, the nuances of cloud deployments, and the best practices for security and performance, all at its fingertips, ready to craft the perfect pipeline for you. So, how does this magic happen? At its core, GenAI models are trained on an enormous corpus of data, thousands upon thousands of CI/CD pipeline configurations, Jenkins files, GitHub Actions YAMLs, GitLab CI/CD files, best practice guides, public code repositories, and documentation for various tools and platforms. When you provide a high-level prompt, perhaps something as simple as, generate a CI/CD pipeline for a Java Spring Boot application that builds with Maven, runs unit tests, scans for vulnerabilities, and deploys to Kubernetes on AWS, the AI leverages its learned knowledge to generate a complete, optimized pipeline definition. It intelligently infers dependencies, suggests appropriate tools, and structures the pipeline logically, tailoring the solution specifically to your project's needs and specified deployment environment. It's like having an expert DevOps engineer who can instantly write flawless, production-ready configurations tailored to your specific requirements. Let's dive into a concrete example, how GenAI can streamline your Java build and test pipelines. When you feed your Java project details to a GenAI, perhaps by allowing it to analyze your pom.xml for Maven or build.gradle for Gradle, it immediately springs into action. The AI understands the conventions of Java development. It knows that a Maven project needs MVN clean install, that a Gradle project requires Gradle build. It can automatically incorporate unit testing frameworks like JUnit or TestNG, ensuring MVN test or Gradle test commands are included. Furthermore, it can intelligently suggest integration test stages, static code analysis checks with tools like SonarQube, and even dependency vulnerability scanning. This capability drastically cuts down the initial setup time, ensuring that your Java applications are built, tested, and validated following industry best practices right from the start, all generated with minimal human input. Beyond building and testing, GenAI truly shines in automating deployment and infrastructure provisioning. Once your Java application is built and packaged, GenAI can generate the necessary artifacts for deployment. This includes crafting optimized Docker files to containerize your Java application, specifying the correct base images, dependencies, and entry points. It doesn't stop there. It can then generate the precise Kubernetes deployment YAMLs, service definitions, and ingress rules needed to deploy your containerized application to a cluster. For cloud-specific deployments, it can even generate infrastructure as code snippets using tools like AWS CloudFormation or Terraform, configuring virtual machines, databases, load balancers, and network settings, all tailored to support your Java application. The AI ensures that environment variables are correctly managed, secrets are securely handled, and scaling considerations are built in, guaranteeing secure, robust, and scalable deployments every single time. Generative AI's capabilities extend far beyond mere structural generation. It can intelligently inject advanced features to elevate your pipelines. Think about security. GenAI can automatically integrate static application security testing, or SAST, tools like SonarQube or checkmarks into your build process, flagging potential vulnerabilities in your Java code before it even reaches a testing environment. It can also suggest dynamic application security testing, DAST, stages using tools like OWASP-SAP, which test the running application for vulnerabilities. On the performance front, the AI can recommend integrating load testing frameworks or performance monitoring tools, ensuring your Java application scales efficiently under heavy loads. Moreover, GenAI can analyze common pipeline bottlenecks and suggest optimizations, such as parallelizing test execution, implementing smart caching strategies for build artifacts, or optimizing Docker image layers, all aimed at significantly speeding up your CI/CD cycles based on a vast knowledge base of successful, optimized pipelines. It's important to remember that the intelligence powering these GenAI capabilities isn't static. These powerful models are part of a continuous learning ecosystem, governed by the principles of MLOps, or machine learning operations. Just like software applications, these AI models need to be continuously trained, evaluated, and deployed. As new Java versions emerge, as new build tools gain popularity, as cloud providers introduce new services, or as security threats evolve, the underlying GenAI models must be updated. MLOps ensures that this feedback loop is robust, collecting new data, retraining models, validating their output, and deploying newer, more capable versions. This continuous improvement guarantees that the GenAI-generated pipelines remain cutting-edge, adhering to the latest best practices, and adapting to the ever-evolving landscape of software development. The benefits of integrating generative AI into your CI/CD workflows are profound and transformative, impacting every stage of your development lifecycle. Firstly, there's a dramatic acceleration in development speed. What once took days or weeks to configure can now be generated in minutes, freeing up valuable developer time. Secondly, it ensures unparalleled consistency across projects. Every pipeline generated adheres to organizational best practices and industry standards, eliminating the snowflake problem where each project has a unique, hard-to-maintain setup. Thirdly, it significantly reduces errors, as AI-generated configurations are far less prone to the human typos and logical mistakes that plague manual processes. Ultimately, GenAI democratizes DevOps, lowering the barrier for developers to implement robust CI/CD practices without needing to be deep DevOps experts. This allows teams to focus intensely on core product innovation, delivering features faster and with higher quality, rather than wrestling with infrastructure configurations. While the promise of GenAI in CI/CD is immense, it's crucial to acknowledge the challenges and look towards the future with a balanced perspective. One key challenge lies in the sheer accuracy and contextual understanding of the generated code. While GenAI can produce highly functional pipelines, human review remains vital to catch nuanced errors, account for specific legacy system integrations, or ensure compliance with unique organizational policies. The security of the training data also presents a critical concern, ensuring no sensitive information leaks into publicly accessible models. Furthermore, an over-reliance on AI without human oversight could lead to a black box problem where developers don't fully understand the generated code. Looking ahead, we can anticipate more sophisticated models that offer real-time feedback loops, self-healing pipelines that adapt to environment changes, and even broader integration with other AI-driven tools across the entire software development lifecycle, pushing us towards truly autonomous and intelligent development environments. And there you have it, a comprehensive look at how generative AI is not just changing but fundamentally transforming CI/CD for Java applications. We've journeyed from the frustrations of manual pipeline setup to the incredible potential of intelligent, AI-driven automation, touching on everything from build and test generation to complex deployment strategies and the critical role of MLOps. This isn't just a futuristic concept, it's a burgeoning reality that promises to make software delivery faster, more consistent, and infinitely more efficient. If you found this exploration insightful, please take a moment to like this video, share it with your fellow developers and students, and subscribe to our channel for more deep dives into the technologies shaping our future. Your support helps us create more valuable content like this. Thanks for watching, and we'll see you in the next one.